solutions for number 6 and number 11. It says copy the vectors in the figure and then use them to draw the following vectors. So number 6 has a vector B pointing kind of up and to the left, and vector A pointing longer but up and to the right, and we're supposed to draw the vector A plus B. Okay, so A plus B, remember if we go tip to tail, we can put another copy of B right here, and the vector A plus B is shown right there. I'll try and do as many of these as I can using the vectors that I drew, but we may need to redraw them. For part B, A minus B, so we'll take a copy of A and then a copy of negative B. So this vector right there would be negative B, and then this vector would be A minus B. Notice if you move its position, it's the other diagonal of the parallelogram that's formed by those two vectors. For C, 1/2 A. 1/2 A is just a vector that's 1/2 the length of A, so it would look like that. Negative 3B, I'll use purple for that one, so that's 3 times the length of B, about like that, going in the other direction, so there's negative 3B. A plus 2B, alright, so A plus 2B, we've got a copy of A, here's a copy of 1 of B, and here's a copy of 2 of B, so putting all that together, we've got this vector right here, that's A plus 2B, looks like we might be able to make it to the end all in one picture, and then 2B minus A, so 2 copies of B, I'll do that in yellow, there's 1 copy, here's 2 copies, and then a copy of negative A put on the end of that, so we're going to go something like this. That would be negative A, and put that all together from beginning to end. You've got this vector here, which is B minus 2A. All right, that takes care of number 6. Let's go on to number 11. In 11, it says, find a vector A with representation given by the directed line segment AB. So let's write down A. A is the point negative 1, 3, and B is the point 2, 2. And we're supposed to find a vector A, which is the same as the direction from A to B. And so we're just going to subtract. We're going to take the x-coordinate of B minus the x-coordinate of A. That gives us 3. And the y-coordinate of B minus the y-coordinate of A. That gives us negative 1. And if we draw that in standard position, it's 3 units to the right and 1 unit down from the origin, which gives us that vector right there.
Hi everyone, we're going to pick up where we left off in class. So this is, we did problem number 11, so we're going to move on to 21 and we'll work through that solution. Okay, so 21 gives us 2 vectors. Vector A is I plus 2j minus 3k. You can think of that as the vector 1, 2, negative 3. And vector B is the vector negative 2, negative 1, 5. I prefer to write it in that notation, so we're just going to go straight to that. So the first question is find vector A plus B. That's just adding the components. So that's negative 1, 1, and 2. And next asks us to do 2A plus 3B. So that's just a linear combination. So 2 of A would be 2, 3 of B would be negative 6, so that gives us first component of negative 4. 2 of A is 4, and 3, so 4 plus negative 3 gives us 1. And then we go with 2, so negative 6 plus 15, that gives us 9. So we've got negative 4, 1, 9. Our next question is the magnitude of A. So magnitude is square root of each component squared and then summed. So we've got 1 squared plus 2 squared plus negative 3 squared. 9 plus 4 plus 1 gives us root 14 is our answer to that one. And then the magnitude of A minus B. So let's first find what A minus B is. So that would be the vector 3, 3, negative 8. And then magnitude would be square root of 9 plus 64, or square root of 82. And that's 21. Okay, next up is 26. So for that one, we've got find a vector that has the same direction as negative 2, 4, 2. but has a length of 6. So let's make a unit vector out of this one, and then we will multiply that by 6, so that has a length of 6. So to make a unit vector, let's find the magnitude. So square root of 4 plus 16 plus 4 gives us root 24, or 2 root 6. So our unit vector would be negative 2 over 2 root 6, 4 over 2 root 6, and 2 over 2 root 6. So that's a unit vector in the same direction as the original. Let's simplify that to be negative 1 over root 6, 2 over root 6, and 1 over root 6. Then to have that vector be a length 6, we'll multiply this vector by 6. So that means that our answer is negative 6 over root 6, 12 over root 6, and 6 over root 6. Okay, and don't worry about rationalizing the denominator. That's not important to me. Okay, 31 and then 34. Okay, so 31 says, a quarterback throws a football with an angle of elevation of 40 degrees and a speed of 60 feet per second. Find the horizontal and vertical components of the velocity vector. Shouldn't be too new to you, even though we didn't do one just like this in class. We're taking a vector and just finding its components in the x and y direction. So magnitude is 60 feet per second, and the angle of elevation is 40. So this component is 60 cosine 40, and this component is 60 sine 40. And we will grab those on the calculator real quick. 60 cosine 40. Okay, so 45.96. And then 60 sine 40. So we'll do that one. 60 sine 40. And that gives us 38.57. So 38.57. There we go.
All right, finally, let's look at number 34. So it says the magnitude of a velocity vector is called speed. Suppose that a wind is blowing from the direction north 45 degrees west at a speed of 50 kilometers per hour. So what this means is that if this is north and this is west, you would think that the wind is blowing like this, but it says it's blowing from that direction, so that's actually not correct. It's actually blowing like this. So we have a vector that's 50 kilometers per hour magnitude, and the kind of the polar representation of that vector would be 50 comma, we'll go with degrees, 315 degrees for its direction. So this is the wind. Okay, a pilot is steering a plane in the direction north 60 degrees east. North 60 degrees east. If this is east, there's north. That means that there's a 30-degree angle here with our 60-degree angle there. And the plane is attempting to fly at 250 kilometers per hour. And so the plane has polar representation, 250 for magnitude, and then 30 degrees for direction, and this is the plane. So the question is, the true course or track of the plane is the direction of the resultant of the velocity and the wind. So we're going to add these, but they can only be added once they are in rectangular form or component form. So our x component is 50 cosine 315, and our y component is 50 sine 315. That's for the wind, and then 250 cosine 30 and 250 sine 30 for the plane. So we're just going to add those down, add x components and add y components, and then we're going to convert back to polar. So let's use the calculator for that. Okay, I did the work on the calculator and I get 251.8 for my x component. I'm going to store that as my x component, store it as x. And then when I combine the two original y coordinates, I get a new y coordinate of 89. So to convert this back to polar, I need to find its magnitude by taking the square root of x squared plus y squared. That gives me a magnitude of 267.3. So that's my speed, and then my direction is going to be inverse tangent of y over x. Sorry. and that gives me 19.59 degrees. Let's just check that that's reasonable. If wind is pushing, that is reasonable. It's going to still be kind of moving in the general easterly direction. So this first component is in kilometers per hour, and the second component gives us our angle from the positive x-axis.